अभी आ रहा है भाई साउंड? So again, a very good morning to all of you बच्चों and welcome to ExamDost. Welcome back to the rank improvement course on power electronics, lecture number 6. Okay, so yesterday I introduced to you the concept of rectifier. I introduced the single phase half wave rectifier. So before we go any further, let us quickly review, recap whatever we covered yesterday. Okay, chaliye. So we covered form factor, which is RMS voltage by average voltage. The closer the form factor to 1, the better DC is the output. Ripple factor is the harmonic RMS by average output under root form factor square minus 1. The lower the ripple factor, the better it is. Okay. Then next, input side. At the AC side, distortion factor is fundamental RMS by total RMS. Then total harmonic distortion under root 1 by G square minus 1. Input power factor G into FDF works for sinusoidal input. Rectification efficiency contribution of the DC component by the total output power V average I average upon V naught RMS I naught RMS. TUF is the DC output power V average I average by VA rating. Now, for single phase half wave uncontrolled rectifier for R load, average is Vm by pi, PIV Vm conduction angle pi. For purely inductive load, average output is 0, current is continuous, diode never stops conduction. RL load, Vm by 2 pi 1 minus cos beta, due to inductor, the extinction angle goes beyond pi and beta has to be calculated numerically. RE load, average voltage has a complex expression, but remember the conduction goes on from theta to pi minus theta, and it is better to approach using the current. Theta is given as sine inverse E by Vm, PIV is Vm plus E. Whenever we connect a freewheeling diode avoids the output from becoming negative, so it will clip the negative part of the output. Okay. For controlled rectifier, R load, the conduction goes on from alpha to pi. Average is Vm by 2 pi 1 plus cos alpha. For L load, the charging discharging interval is equal. So inductor charges from alpha to pi and discharges from pi to 2 pi minus alpha. For RL load, conduction goes from alpha to beta. For RE load, conduction goes from alpha to pi minus theta. Alpha to pi minus theta. So remember, for RLE load, the beta will be greater than pi minus theta and it has to be calculated using AC transient. अब मुझे बताइए भाई, अगर किसी को कोई डाउट है जितना अभी तक कवर किया है. If you have any doubt in the half wave rectifier, let me know बच्चों. Come on everybody. Is there any doubt in the half wave rectifier? And just give me a moment. हाँ डाउट आया बेटा सर प्लीज एक्सप्लेन बीटा। बीटा का मतलब होता है बेटा द एंगल एट विच करंट बिकम्स जीरो, और यू कैन से योर डिवाइस टर्न्स ऑफ। डिवाइस बंद हो जाती है बीटा पे जा करके। तो आपको ये देखना होता है जब आप करंट का वेवफॉर्म बनाओगे तो किस एंगल पे करंट आपका जीरो हो जा रहा है, दैट इज कॉल्ड एज बीटा। ठीक है, चलें आगे। आइए, we will talk about full wave rectifier. In full wave beta, first I will talk about the midpoint rectifier. Now today our major focus is going to be on highly inductive loads, that is the loads where I naught remains constant. The inductance in the load is so large that your I naught will stay constant. So load current is ripple free. There is no fluctuation in I naught. And this kind of a load is also called as current stiff, which means I naught cannot change suddenly. I naught अचानक से नहीं बदल सकता. So that is said to be current stiff. So see, this is a midpoint converter beta, where we have a transformer. The ratio of transformer is 1:2, or you can say n:2n. The secondary is a center tapped winding. We also call it a center tap transformer. Now, one thing you must always remember, beta, whenever we give you a highly inductive load, whenever the question says load is highly inductive, it means load demands a constant current. So at all time, at each value of t, there should be a path present for the flow of current. t का आप कोई भी वैल्यू उठा के देख लीजिए, करंट फ्लो का कोई ना कोई रास्ता होना चाहिए. Now in this circuit beta, current can flow via two paths. Either the upper loop, this is my load RL load having a large inductance, current can flow either in the upper loop or current can flow in the lower loop. So because I naught is constant, that means one of the two paths should always be present. दो में से कोई एक तो हमेशा present होना चाहिए. Which means either of the devices should always be conducting. दोनों में से कोई एक डिवाइस को हमेशा on रहना पड़ेगा. Now see, during the positive half cycle, the dot is positive. On the secondary also dot is positive. ठीक है, because positive dot is connected to anode, the SCR is forward bias. Negative is connected to anode, it is reverse bias. So this will be forward biased in the positive half cycle. But does it start conducting immediately? No, beta. It will conduct alpha angle after forward biasing. So this gets forward biased at 0 degree, but it will conduct at alpha. 0 पे forward तो हुआ, conduction alpha से चालू करेगा. Similarly, beta, during the negative half cycle, the polarity of the supply will be reversed. So dot will be negative. Dot will be negative. Which means negative is connected to anode, reverse bias. Positive connected to anode, it is forward bias. So T2 becomes forward bias during the negative half cycle, and negative half cycle starts at pi. So you can say T2 becomes forward biased at pi. But does it start conducting immediately? No, it will start at pi plus alpha. Now listen carefully, beta. This thyristor is getting forward biased at 0 degree, but it starts to conduct at alpha. And the next SCR gets forward biased at pi, but it will start to conduct at pi plus alpha, which means from alpha to pi plus alpha, T1 will be on, and from pi plus alpha to 2 pi plus alpha, T2 will be on. So T1 is on at alpha, it will continue to conduct until T2 turns on. T1 अल्फा पे चालू हो गया तो जब तक T2 ना आ जाए T1 की जिम्मेदारी है, और T2 पाई प्लस अल्फा पे चालू हुआ, जब तक दोबारा से T1 ना आ जाए T2 की जिम्मेदारी है। तो T2 कंडक्ट करेगा पाई प्लस अल्फा से लेकर के 2 पाई प्लस अल्फा तक। तो नाउ बेटा whenever the T2 conducts, देखिए the blue voltage is actually Vs, the pink voltage is minus Vs. So when T1 conduct, output will be Vs. When T2 conducts, the pink voltage will be the output, that is minus Vs. So that is why beta I have drawn the red graph as Vs and the blue graph as minus Vs. So when T1 is conducting from alpha to pi plus alpha, I will follow the red graph. I will follow the red graph. And when T2 conducts from pi plus alpha to 2 pi plus alpha, I will follow the blue graph. समझे? मैं रेड ग्राफ को फॉलो करूंगा जब मेरा T1 होगा, और जब मेरा T2 चालू होगा तो ब्लू वाले ग्राफ को करूंगा. So I get the output as this green waveform. Now I naught is constant beta. I naught is constant. Now whenever T1 is conducting, this is how the current will flow. On secondary it is leaving the dot. So primary current will enter the dot. So Is will be I naught. Now here when T2 is conducting, current is entering the dot on secondary, तो current will be leaving the dot on primary. जब T2 चालू होता है तो करंट डॉट में घुस रहा है, तो यहां डॉट से निकलेगा, तो Is will be minus I naught. Now you might think, sir, when we are referring, why are we not using the turn ratio? जब हम सेकेंडरी से प्राइमरी करंट रेफर कर रहे हैं तो टर्न रेशियो क्यों नहीं यूज कर रहे? Because beta the secondary has 2n turns, but out of the 2n turns only n turns are working at a time. भले ही 2n turns हैं, but एक समय पे n turns काम करते हैं, या तो ऊपर वाले n या फिर नीचे वाले n. Therefore the current is same in primary and secondary. करंट दोनों पे सेम आता है. So now beta when T1 is on, current is I naught, T2 is on, minus I naught. T1 is on, I naught. So this is a proper square wave, and because I am getting a proper waveform, now I can find its RMS. I can find its Fourier series. So yesterday what was happening in RL load, I was not getting a proper waveform for the current, and hence I was not able to determine the RMS current. इसीलिए मैं RMS current नहीं निकाल पा रहा था. But now why can I find? Because I am getting a proper square wave. So it is very easy for me to find the RMS current. Is that clear? Then if you talk about the thyristor voltage beta, when T1 is on, voltage is 0. T1 is on, voltage is 0. But when it is off, the voltage is 2 times the supply voltage. Why, sir? Because the secondary has 2n turns, so total secondary voltage is 2 Vs. Secondary पे 2n turns है, तो secondary की total voltage 2 Vs है. Similarly, when T2 is on, the voltage is 0. When T2 is on, the voltage is 0. But when it is off, the voltage is minus 2 Vs. Minus 2 Vs. So that is why beta the peak inverse voltage becomes 2 Vm. PIV कितना हो जाता है? 2 Vm हो जाता है. And that is the disadvantage, that PIV is very high, which can lead to damage of the thyristor. If you do not want the thyristor to be damaged, you have to purchase a thyristor having higher voltage rating. अगर डैमेज से बचाना है तो ज्यादा वोल्टेज रेटिंग वाला थायरिस्टर परचेज कीजिए. नाउ बिकॉज करंट इज अ स्क्वायर वेव, शिफ्टेड स्क्वायर वेव, दिस इज द फोरियर सीरीज. वी हैड ऑलरेडी स्टडीड दिस, राइट? अगर करंट एक शिफ्टेड स्क्वायर वेव होता है तो ये फोरियर सीरीज हम जानते हैं. नाउ द सर्किट टर्न ऑफ टाइम, देखिए this thyristor stopped conducting at pi plus alpha. It was forward biased at 0. Next time it will be forward biased at 2 pi. But it stopped the conduction at pi plus alpha. So time of second forward biasing minus extinction angle by omega. किस समय पे दूसरी बार फॉरवर्ड बायस होगा और माइनस बंद कब हुआ? So that is your circuit turn off time. Circuit turn off time. Or I already told you beta PIV is 2 Vm. Now average output comes as 2 Vm by pi cos alpha. Supply current is a square wave. So RMS is same as the peak value. Fundamental RMS. Take the peak value 4 I naught by pi n equal to 1. For fundamental n equal to 1. 4 I naught by pi. Okay. 4 I naught by pi, then divide it by root 2. So 2 root 2 by pi I naught. कितना? 2 root 2 by pi I naught. Now if you see the fundamental current here, अगर आप fundamental current देखिएगा बेटा, 4 I naught by pi sin omega naught t minus alpha. Okay. So now what is the supply voltage? Vm sin omega naught t. So what is the phase shift? Phase shift is alpha. So FDF will be cos alpha. And I am just dividing the peak value by root 2 to find out the value of RMS current. Okay. PIV circuit turn off time I told you. Now the distortion factor is fundamental RMS by total RMS. Fundamental RMS by total RMS, it is 0.9. THD 1 by G square minus 1, 48.4%. 48.4%. समझे भाई? बताओ यहाँ पे अगर किसी को कोई डाउट है? Anybody having any doubt? नहीं बेटा, मॉर्निंग क्लास सिर्फ वीकेंड पे होगा, सैटरडे संडे. कल भी लूंगा, सेम टाइम लूंगा 11:30 बजे. ठीक है? सिर्फ मॉर्निंग क्लास 2 ही दिन, सैटरडे संडे. आपके ऐप से 13 एंड 14 का पीडीएफ, लेक्चर 3 एंड 4 का पीडीएफ डाउनलोड नहीं हो रहा है. व्हाट्सएप पे इन्फॉर्म कर दो, टीम एक बार चेक कर लेगी अगर सेटिंग में कुछ गड़बड़ है. क्लियर हुआ यहां तक? बोलो भाई, ये क्लियर हुआ? नाउ वी कम टू द ब्रिज टाइप रेक्टिफायर. व्हाट इज द डिसएडवांटेज? What is the disadvantage of midpoint rectifier is high PIV. अगर गेट प्रिपरेशन से मेरा सीजीपीए 6 रह जाता, जसवंत भाई पहली बात तो गेट प्रिपरेशन से सीजीपीए गिरे ऐसा होना प्रैक्टिकली इम्पॉसिबल है, क्योंकि अगर गेट की तैयारी कर रहे हो, टेक्निकल सब्जेक्ट अच्छा कर रहे हो, तो टेक्निकल में मार्क्स कॉलेज में भी अच्छे आने चाहिए. और किसी एग्जाम की वजह से अगर सीजीपीए गिरता तो समझ में भी आता, गेट में तो कॉलेज का ही सिलेबस पढ़ रहे हो. तो मिड पॉइंट कन्वर्टर has a drawback of high PIV. ठीक है? मिड पॉइंट कन्वर्टर हैज अ ड्रॉबैक ऑफ हाई PIV. जनरली सेम रहता है संदीप भाई. अगर मुझे आपको परेशान करना है, क्वेश्चन में ज्यादा टिपिकल बनाना है, तो यस, आई कैन हैव डिफरेंट फायरिंग एंगल फॉर T1 एंड T2. यस, दैट कैन हैपन. ठीक है? डेप्थ में पढ़ते भी हो तो बेटा एक समय पे 2 सब्जेक्ट लेके चल सकते हो. जसवंत, तो एक सेमेस्टर में आपके 4 या 5 सब्जेक्ट होते हैं, उतना तो वैसे भी कवर हो जाएगा. अगर एक महीने में 2 सब्जेक्ट कवर करें तो 2 महीने में 4 सब्जेक्ट तो हो ही सकते हैं. एसएससी जेई वालों में बेटा इतना पावर इलेक्ट्रॉनिक्स आता ही नहीं सरिता की करने की जरूरत पड़े. अब आगे बढ़ते हैं भाई. तो दैट इज वाई बेटा वी कम टू ब्रिज रेक्टिफायर. नाउ इन ब्रिज रेक्टिफायर, इंस्टेड ऑफ 2 थायरिस्टर वी हैव 4 थायरिस्टर. And at a time 2 thyristors will conduct together. Again I am taking a highly inductive load, which means the time constant is very high, load current is ripple free, and I naught is constant. Because I naught is constant beta, sometimes it will be represented as a current source. बहुत बार ना इसको current source की तरह दिखाते हैं. Now you see, from alpha to pi plus alpha, T1, T2 will conduct. From pi plus alpha to 2 pi plus alpha, T3, T4 will conduct. So T1, T2 in the positive half cycle, T3, T4 in the negative half cycle. So during the first half cycle, alpha to pi plus alpha, T1, T2 are going to turn on, and from pi plus alpha to 2 pi plus alpha, T3, T4 are going to conduct. And the current waveform is same. But the only thing is, beta, there is no transformer which will double the voltage, because of which the PIV is VM. Everything is same. The only thing that changes is PIV comes out to be VM rather than 2 VM, because there is no transformer which will double the voltage. Okay? कोई ऐसा ट्रांसफॉर्मर ही नहीं है बच्चों मेरे पास जिससे कि मेरा वोल्टेज डबल हो जाए. बात समझ में आ रही है? तो बेसिकली here the advantage is that your PIV comes out to be VM, so you can use a rectifier having lower rating. आप रेक्टिफायर कम रेटिंग वाला भी इस्तेमाल कर सकते हो. ठीक है? So you can say PIV becomes VM. So SCR of lower voltage rating can be used. ठीक है? Rest of the parameters will remain the same, and there is no center tapped transformer. Okay. So like the average will remain the same, 2 Vm by pi cos alpha. Total supply RMS, fundamental RMS, FDF, PIV becomes VM. Circuit turn off time remains the same. Reactive power. Now this is important. Once you know the FDF, you can find the reactive power. If FDF is cos alpha, that means power factor angle is alpha. So you find the real power. Because I naught is constant, the real power is derived by multiplying V average into I naught. क्योंकि I naught constant है बेटा, तो पावर निकालने के लिए V average का इस्तेमाल किया जाएगा. Okay, we will make use of the average output. Now once we have the real power, we can find reactive power as P tan alpha, because power factor angle is alpha, so we can apply P tan alpha. Okay. Now, distortion factor is fundamental RMS by total RMS, that is 2 root 2 by pi, which is 0.9. Input power factor is G into FDF. THD also comes out to be same, 48.4. Now, when we are talking about the thyristor RMS current, thyristor conducts for pi angle. How? From alpha to pi plus alpha. So for pi angle, out of 2 pi, so I am scaling the current I naught under root duration by period. PIV is VM, so our work is done. Now beta, this highly inductive load is highly important for gate. So when I say you have to memorize the formula, you have to memorize just for the highly inductive load. सिर्फ हाईली इंडक्टिव लोड के लिए ही आपको मेमोराइज करना होगा. सर मेरा एज 28 है, क्या मैं अभी प्रिपेयर करना सही होगा? यार देखो, एमटेक के लिए जा सकते हो, बहुत सारी पीएसयूज में तो चांस नहीं बनेगा इस एज पे. नाउ व्हाट इफ द लोड इज रेजिस्टिव? So remember, whenever the load is resistive, V naught cannot become negative, because if the voltage becomes negative, current will be negative, but the thyristors do not allow negative current. That is why conduction has to stop at pi. So T1, T2 will not conduct from alpha to pi plus alpha, but they will conduct from alpha to pi. T1, T2 अल्फा से पाई प्लस अल्फा तक नहीं जाएंगे, ये सिर्फ अल्फा से पाई तक जाएंगे. And T3, T4 will not conduct from pi plus alpha to 2 pi plus alpha, but they will conduct from pi plus alpha to 2 pi. So now beta, when we are taking the average, it is full wave rectifier, so period is pi. Integration will be from alpha to pi. So it will come out as Vm by pi 1 plus cos alpha. Okay? And I average will be V average by R. I RMS will be V RMS by R. So you see, these negative glitches are deleted. ये जो negative वाला portion है delete हो गया, because V0 cannot be negative in case of a resistive load. For RMS beta, I will take the period as pi. Integration from alpha to pi, because conduction stops at pi. Now I will take square of the voltage. So this comes out as the RMS output voltage. Now thyristor conduction angle is pi minus alpha. And because conduction stops at pi, and next time it will be forward biased at 2 pi. So you can find circuit turn off time as time of second forward biasing minus when does the conduction stop divided by omega. Second time forward bias कब होगा minus conduction कब रुका divided by omega. Okay, so that is the parameters. Next is a purely inductive load. Now beta, in purely inductive load, it is very important that for stable operation, inductor must be able to completely discharge. Stable operation के लिए क्या condition होती है? For stable operation, inductor must have equal charging and discharging. So in a full wave rectifier beta, for getting equal charging and discharging, your alpha should be greater than equal to 90 degree. If alpha is less than 90, the charging is more than discharging. The positive area of V0 is greater than negative area. So charging is more than discharging. If that happens beta, then operation would be unstable. अगर discharging से ज़्यादा charging होगी, तो current will increase in every cycle and it will become unstable. Okay, see. Suppose I take alpha equal to 120. So alpha is 120. So first of all, at 120, T1, T2 will turn on. They will charge the inductor up to 180 degree. That is for 60 degree. For next 60, they will discharge. Now T3, T4 will conduct at pi plus alpha. That is 300 degree. So they will charge till 360 and discharge for next 60 degree 420. So that is T1, T2 will conduct from 120 to 240, equal charging and discharging. Then T3, T4 will start from pi plus alpha, that is 300 degree. So again, equal charging and discharging. What if alpha is 90? So now beta, from 90 to 180 it will charge. From 180 to 270 discharge. Okay. Now T3, T4 start at pi plus alpha or 270. They charge till 360 and then discharge for the next 90 degree. Okay. So charging for 90, discharging for 90, charging for 90, discharging for 90. Here current is just touching 0. It does not stay at 0. So this is called boundary condition. and when current stays at zero for some duration, it is called discontinuous conduction. अगर करंट थोड़ी देर के लिए जीरो पे रुकता है तो उसे कहते हैं डिसकंटिन्यूअस कंडक्शन, और अगर जीरो को सिर्फ टच करके वापस आ जाए तो उसे कहते हैं कंटिन्यूअस कंडक्शन। और संडे को सिर्फ इसी वीक में क्लास ले रहा हूं क्योंकि अगले वीक में मुझे हो सकता है एक दिन ऑफ करना पड़े, तो मैं नहीं चाहता कि आपके कोर्स में एक भी दिन का इंक्रीमेंट आए, ठीक है। तो ऐसा नहीं है कि हर संडे क्लास लगेगी, सिर्फ इसी संडे ऐसा हो, क्या भाई। तो जब भी संडे क्लास लगेगी वो किसी बेसिकली लीव को या हॉलीडे को कंपेंसेट करने के लिए होगी, ताकि शेड्यूल अप डाउन ना हो। ओके बेटा, नाउ you can write L di by dt as Vm sin omega t. Di will be Vm by omega L sin omega t d omega t. Now current starts at zero when angle is alpha. Current is I at omega t. So we get this equation, but remember alpha should be greater than equal to 90. Alpha less than 90 में क्या होगा बेटा, ये पॉजिटिव वाला जो एरिया है ना ये ज्यादा होगा, नेगेटिव वाला कम होगा। जैसे बख्शी जी मान लीजिए 60 डिग्री लिया, ठीक है, मान लीजिए यू टुक अल्फा इक्वल टू 60, तो फ्रॉम 60 टू 180 देयर विल बी चार्जिंग फॉर 120 डिग्री। नाउ यू एक्सपेक्ट दैट फॉर नेक्स्ट 120 देयर शुड बी डिस्चार्जिंग, शुड बी, ठीक है। आप कह रहे हो सर 60 से 180 तक चार्ज हुआ, 120 तो 300 तक डिस्चार्ज होना चाहिए। नाउ व्हाट इज द स्टार्टिंग एंगल ऑफ T3 T4? 180 plus alpha. Alpha is 60. Which means they will start at 240. You want to discharge the inductor till 300, but T3 T4 start conducting at 240 and they will again start to charge the inductor. आप तो ये सोच के बैठे हो कि T1 T2 कंडक्ट करेंगे 60 से 180 चार्ज और 180 से 300 डिस्चार्ज, लेकिन इससे पहले कि पूरा डिस्चार्ज हो 300 तक हम जाएं, 240 पे T3 T4 आ जाएंगे जो वापस से चार्ज करना स्टार्ट कर देंगे, और इससे होगा क्या, इससे आपका करंट लगातार बढ़ते जाएगा, इट विल नेवर बिकम जीरो, ओके, इट विल कीप ऑन इंक्रीजिंग। बात समझ में आई? इट विल कीप ऑन इंक्रीजिंग। नेक्स्ट, सपोज आई हैव अ फ्रीव्हीलिंग डायोड. Now what does freewheeling diode do? Just like a R load, it does not allow V0 to become negative. So beta, in a highly inductive load, the output is negative. The output is negative from pi to pi plus alpha. So whenever output is negative, freewheeling diode turns on. So from pi to pi plus alpha it will conduct. From 0 to alpha also it will conduct. तो फ्री व्हीलिंग डायोड कहां कंडक्ट करेगा, 0 से अल्फा और पाई से पाई प्लस अल्फा। तो द V0 वेवफॉर्म विल बी जस्ट लाइक अ R लोड, दीज नेगेटिव पोर्शंस विल बी डिलीटेड। ये नेगेटिव पोर्शंस आपके डिलीट हो जाएंगे। तो सी हियर योर फ्री व्हीलिंग डायोड विल कम इनटू पिक्चर, ठीक है। यहाँ पे जो 0 से अल्फा है या पाई से पाई प्लस अल्फा है, फ्री व्हीलिंग डायोड विल कम. So when you talk about the supply current, when T1, T2 are on, it is I0. When T3, T4 are on, minus I0. So this is a quasi square wave. When freewheeling diode is conducting, na, that time your supply current would be 0. When freewheeling diode is on, no current comes from supply, but I0 circulates in a loop. ठीक है, I0 एक लूप में घूमेगा. ठीक है, इसीलिए IS 0 है. Now we have already seen the Fourier series of this waveform. 4I0 by pi cos n alpha by 2 sin n omega t minus n alpha by 2. This is a quasi square wave. Sir, what if I wanted to plot the freewheeling diode current? So you will show beta small pulses from 0 to alpha, it will be I0. From pi to pi plus alpha, it will be I0. 2 पाई टू 2 पाई प्लस अल्फा इट विल बी आई नॉट. जैसे ये आ रही है ना पल्सेस, ऐसी आएगी बट 0 से अल्फा, पाई से पाई प्लस अल्फा, 2 पाई से 2 पाई प्लस अल्फा, ऐसी पल्सेस बनेंगी. So this is my fundamental. I have put n equal to 1. So freewheeling diode is conducting for 2 alpha. कैसे? 0 to alpha and pi to pi plus alpha. What about thyristor? Thyristor conducts from alpha to pi. So conduction angle is pi minus alpha. Average output I told you same as the resistive load. Now circuit turn off time. So the T1, T2 turned off at pi. Now they will again be forward biased at 2 pi. So just like our load, 2 pi minus pi by omega. Now FDF, because the voltage will be Vm sin omega t. So the shifting between voltage and fundamental current is alpha by 2. So it is cos alpha by 2. Fundamental RMS divided by root 2, 2 root 2 by pi I naught cos alpha by 2. Total RMS, it is a quasi square wave. So the duration is pi minus alpha in a half cycle of pi. So how to scale the RMS of a flat graph? I naught under root duration by period. Now G, fundamental RMS by total RMS, it will depend on alpha. Input power factor G into FDF, THD under root 1 by G square minus 1. This is also called as a semi-converter. Why semi-converter? Because beta you are using SCR as well as diode, which means mere bachcho, few devices are controlled, SCR is controlled, but diode is uncontrolled. So when we are using a mix of controlled and uncontrolled devices, it is said to be semi-controlled. ठीक है, कंट्रोल्ड और अनकंट्रोल्ड दोनों का अगर आप यूज कर रहे हो तो उसको कहते हैं सेमी कंट्रोल. इज दैट क्लियर टू एवरीवन? बताइए, इज दैट क्लियर टू एवरीबॉडी? ओके, चलिए. नेक्स्ट, if you have a RE load, yesterday what did we learn about RE load? That SCR does not get forward biased at 0 degree, but it will be forward biased at theta, which is sine inverse E by Vm. But because it is SCR, it does not start to conduct immediately at theta. It will start to conduct at alpha, where alpha is greater than theta. So T1, T2 will be forward bias from theta to pi minus theta, and T3, T4 will be forward biased from pi plus theta to 2 pi minus theta. But they will be on from alpha to pi minus theta. ठीक है? T1, T2 on from alpha to pi minus theta. T3, T4 will be on from pi plus alpha to 2 pi minus theta. And we are taking alpha greater than theta. Alpha is greater than theta. Okay. Is that clear? So now beta, if you see, when T1, T2 are conducting, then output is same as the red curve, that is Vs. When T3, T4 are conducting, the output is same as blue curve, that is minus Vs. And when none of them is conducting, then output is E. जब कोई भी conduct ना करे तो output E है. So what change you have to do beta? It is always easier to approach via current. So remember that conduction is happening from alpha to pi minus theta. And what will be the current? Current will be supply minus E by R. Vm sin omega t minus E by R. You just have to integrate from alpha to pi minus theta. Just like yesterday. But the period is pi instead of 2 pi. कल जो आपका पीरियड था ना वो 2 पाई था, तो आप डिवाइड 2 पाई से कर रहे थे, आज आपको डिवाइड सिर्फ पाई से करना है. देन V एवरेज इज E प्लस I एवरेज इंटू R. And for RMS beta, for RMS, what happens is same logic, but use the square of the current and take the under root. और बाद में क्या कर लीजिएगा, रूट ले लीजिएगा. ठीक है, दैट इज योर RE लोड. What about RLE load? In RLE load, beta, due to inductor, the conduction will go beyond pi minus theta. But now remember, T3, T4 are going to start at pi plus alpha. हमें ये पता है, if T1, T2 are starting at alpha, T3, T4 are going to start at pi plus alpha. Correct? But if the conduction of T1, T2 goes beyond pi plus alpha, that is, if beta is more than pi plus alpha, then before T1, T2 can stop, T3, T4 will start to conduct. इससे पहले कि मेरे T1, T2 बंद होते, मेरे T3, T4 कंडक्ट करना चालू कर देंगे. So they will start to conduct before T1, T2 can turn off, which means conduction will be continuous. आप ये समझिए, T1, T2 इससे पहले कि बंद हो पाए, T3, T4 आपके चालू हो जाएंगे, तो कंडक्शन आपका कॉन्टिन्यूअस बनने वाला है. और जब भी कॉन्टिन्यूअस कंडक्शन होगा, RLE load will behave like a RL load. In terms of the formula, whatever you have studied, your RLE load will give you the same expressions as the highly inductive load. Highly inductive load वाले ही फॉर्मूला आपको मिलने शुरू हो जाएंगे. ओके, ये बात क्लियर हुई? तो V0 will be 2Vm by pi cos alpha, I0 will be V0 minus E by R. Is that clear? But if beta is less than pi plus alpha, it is discontinuous conduction. So T1, T2 will conduct from alpha to beta, T3, T4 from pi plus alpha to pi plus beta. Now, when you are taking I average, inductor does not play any role in the average current. Period is pi. Integration from alpha to beta, Vm sin omega t minus E by R. Vm sin omega t minus E by R. Okay. And V average will be I average into R plus E. So see, if beta is greater than pi plus alpha, you will get exactly same waveform as that of a RL load. Okay. So conduction angle of thyristor will be pi, PIV will be Vm. Circuit turn of time is also same, pi minus alpha by omega. Now, when we talk about a semi-converter, one way of making a semi-converter is to connect a freewheeling diode with a full converter. Because as soon as you introduce the diode, you can say all my devices are not SCR or all my devices are not controlled. जैसे ही डायोड आता है तो आप कह सकते हो कि मेरी सभी डिवाइसेस कंट्रोल्ड नहीं है, कुछ डिवाइसेस अनकंट्रोल्ड भी हैं, जिस वजह से इट विल बी टर्म्ड एज सेमी कंट्रोल्ड. बट देयर इज अनदर वे ऑफ मेकिंग अ सेमी कन्वर्टर दैट यू आर यूजिंग 4 SCR इन ब्रिज कॉन्फ़िगरेशन. रिप्लेस 2 ऑफ दोज SCR विद डायोड. आप उन 4 में से 2 SCR को डायोड बना दो तो भी आपका सेमी कन्वर्टर बनेगा. Does current increase here if beta is greater than pi plus alpha? Actually, Sandeep bhai, always remember, average value is higher in a discontinuous conduction rather than continuous. So if beta is greater than pi plus alpha, average will actually be smaller. Average कम आएगा continuous में. So in symmetrical beta, in each vertical leg, instead of having 2 thyristor, I have a thyristor diode. मेरे पास 2 thyristor आने की जगह एक thyristor, एक diode, एक thyristor, एक diode आता है. Now, it is also called as symmetrical because the conduction angle of thyristor and diode both is pi. So now, from alpha to pi, remember the diodes do not see What is the firing angle? ठीक है, diode conduction is independent of alpha. First thing, if I naught is constant, one device from upper group and one from lower group must be on. देखिएगा, this diode will conduct from 0 to pi. So beta, from this will start at alpha. So from alpha to pi, T1, D2 will conduct. V0 will be Vs, Is will be I0. But after pi, beta, D4 starts. As soon as D4 starts, D2 has to turn off. जैसे D4 चालू होगा तो नीचे वाले ग्रुप में से मजबूरन T2 को बंद होना पड़ेगा. But T3 does not turn on. T3 turns on at pi plus alpha. So from the upper group, T1 will conduct, and from the lower group, the diode has turned on. So you will get a freewheeling path. आपको एक freewheeling path मिल गया. So V0 will be 0, Is will be 0. Now at pi plus alpha, T3 turns on. So T1 will turn off. Now pi plus alpha to 2 pi, T3, D4 will conduct. So V0 will be minus Vs, Is will be minus I0. After 2 pi, D2 will be on. But T1 cannot be on until 2 pi plus alpha. पहले अल्फा पे चालू हुआ था ना, अगली बार 2 pi plus alpha पे होगा. So T1 is still not on. So T3, D2 will conduct. Again you will get a freewheeling path. So whenever two devices in the same branch are conducting, we will get a freewheeling action. And V0 will be 0, Is will be 0. जब भी एक लेग की दो डिवाइस कंडक्ट करेंगी तो फ्री व्हीलिंग एक्शन बनता है, वोल्टेज और करंट दोनों जीरो आते हैं. तो नाउ इफ यू सी, दिस इज सेम एज द आर लोड, और यू कैन से इट इज सेम एज द फुल कन्वर्टर विद फ्री व्हीलिंग डायोड. सेम वेव फॉर्म आती है, एग्जैक्टली सेम. बट द थिंग इज कि इन अ सिमेट्रिकल सेमी कन्वर्टर, थायरिस्टर एंड डायोड बोथ हैव द सेम गामा. दोनों का गामा सेम आता है. So the parameters are absolutely same what you studied for a full converter with freewheeling diode. But when you are computing the average current of thyristor and diode, scale I0 with pi by 2 pi, or RMS scale it by under root pi by 2 pi, duration by interval. In asymmetrical beta, in one leg you have two thyristors, and in one leg you have two diodes. So this D2 will turn on at 0, D3 will turn on at pi, T1 will turn on at alpha, T4 at pi plus alpha. तो देखिए, this is on at alpha. So from alpha to pi, T1, D2 are conducting. But at pi, D3 turns off. It does not care about alpha. As soon as D3 turns on, T1 has to turn off. So T1 turns off at pi, but T4 is still not on. T4 waits till pi plus alpha. So D2 has to conduct because load is demanding constant current. लोड कह रहा है भाई मुझे तो कांस्टेंट करंट चाहिए. अब T4 कह रहा है अभी तो मैं स्टार्ट नहीं होऊंगा पाई प्लस अल्फा तक, तो मजबूरन D2 को कंडक्ट करना होगा. तो D3, D2 will provide a freewheeling path. Now at pi plus alpha, T4 is on. So D2 turns off. Now T4 and D3 will conduct till 2 pi. So V0 will be minus Vs and Is will be minus I0. But at 2 pi, D2 will be on. As soon as D2 is on, T4 turns off. But T1 is not on. T1 will be on at 2 pi plus alpha. So again D3 D2 conducts from 2 pi to 2 pi plus alpha, providing freewheeling, which means the freewheeling action in both the time is provided by only one branch, because of which conduction angle of diode is higher, pi plus alpha, conduction angle of thyristor is smaller. पहले क्या हो रहा था बेटा, दोनों ब्रांचेस बारी बारी फ्री व्हीलिंग दे रही थी. लाइक दिस वाज प्रोवाइडिंग फ्री व्हीलिंग फ्रॉम पाई टू पाई प्लस अल्फा, दिस वाज प्रोवाइडिंग फ्री व्हीलिंग फ्रॉम 0 टू अल्फा. But now freewheeling action is only provided by diode branch. So the diode conduction angle is higher, thyristor conduction angle is smaller. And that is also one of the reason we call it asymmetrical. So rest everything remains the same, only the thyristor conduction angle and the diode conduction angle changes. सिर्फ थायरिस्टर और डायोड का कंडक्शन एंगल बदल गया भाई. Like this. Is that clear? So the thyristor average will be I naught thyristor RMS like this. So these parameters are going to change. Now बेटा फुल कन्वर्टर विथ फ्री व्हीलिंग डायोड, ये तो हम देख ही चुके हैं बेटा, ये तो हम लोग देख ही चुके हैं. ये मैंने आपको बता दिया. Now suppose there is RE load. Now beta in RE load anyways the output never becomes negative. The output voltage can never go below E. Output voltage कभी भी E के नीचे नहीं जाएगा. And because it does not go below E, there is no point of freewheeling. Freewheeling की बात होगी ही नहीं. Okay? फ्री व्हीलिंग की बात ही नहीं होगी. तो फुल और सैमी का बिहेवियर सेम है. ठीक है. नाउ व्हाट इज द शॉर्टकट बेटा? फॉर हाफ वेव यू कैन रिमेंबर दिस एवरेज एंड द आरएमएस आउटपुट वोल्टेज. ये याद कर लो. ठीक है. ये आरएलई लोड के फॉर्मूले हैं, अगर आप आरएलई लोड का याद करना चाहते हो. फॉर फुल वेव इंस्टेड ऑफ 2 पाई देयर विल बी पाई. बस यही तो है. यहां देखो 2 पाई है, 2 पाई है, यहां पे पाई है, पाई है. नाउ हाउ कैन यू यूज दिस फॉर्मूला फॉर डिफरेंट टाइप ऑफ लोड? So if the converter is uncontrolled, use alpha equal to theta, which means sine inverse E by Vm. But if there is no EMF in the load, so E will be 0, theta will be 0. And for controlled rectifier, use alpha. Now beta is pi minus theta for RE load. Beta is pi for R load. EMF is 0. Beta is more than pi for RL load. E is 0. Beta is more than pi minus theta for RLE load. That is only for discontinuous. ये जो formulae है ना, these are for discontinuous conduction. For continuous conduction in full converter, you already know 2 Vm by pi cos alpha, valid for RL and RLE. And then I naught is V naught minus E by R. तो ये सारे फॉर्मूला की लिस्ट मैंने बेटा आपको प्रोवाइड कर दी है. चलिए come to this beta. A single phase full wave midpoint converter uses a center tap transformer with 230 volt across each half of the secondary. ये secondary के half पे voltage है So what is the PIV of each thyristor? चलो बताओ, PIV कितना आएगा? Yes, 2 Vm. For midpoint converter, it is 2 Vm. Next, for a single phase fully controlled bridge converter with a highly inductive load and firing angle alpha, the fundamental component of input current lags the fundamental source voltage by phi 1. What is the relation between phi 1 and alpha? बताइए. Phi 1 is alpha because in a full converter FDF is cos alpha. Next, in a single phase full converter with R load, the conduction angle for each thyristor pair is, if it is a R load, what is gamma? R load के लिए gamma क्या होता है? Pi minus alpha. For highly inductive load, it is pi. For R load, it is pi minus alpha. A single phase semi converter is operating with a firing angle 60 degree. For what duration does the freewheeling diode conduct? Sir, in RRB CBT2, I got 97 marks, not selected. तो तुम्हारे जोन का कट ऑफ कितना गया था अविनाश भाई? It is 2 alpha. मैंने बताया था ना, from 0 to alpha and pi to pi plus alpha. The input power factor of a single phase full wave bridge converter with a highly inductive load is K cos alpha. What is the value of K? बताओ. What is the value of K? अगर input power factor K into cos alpha है तो K क्या है? K is 2 root 2 by pi, which is basically G. Distortion factor. In asymmetrical semi-converter, one leg with 2 SCR, other leg with 2 diode. Average current through a diode is? बताइए. Average current through a diode is? Greater than thyristor because conduction angle of diode is pi plus alpha. Conduction angle of thyristor is pi minus alpha. Next, in a single phase full converter supplying RLE load, expression for average output current in DCM, this continuous conduction mode is given. What does the term beta represent? Very easy. Beta क्या है? बताइए. What is beta? Extinction angle. Which of the following statement are advantages of single phase semi converter over a fully controlled converter? Single phase semi converter over fully controlled converter. It can operate in inverter mode. No. It has better input power factor. Yes. Cos alpha by 2 is better than cos alpha. It does not require freewheeling diode. Okay. The input has lower THD. Yes. Less harmonics. Full converter के मुकाबले less harmonics. के ख्याल से freewheeling diode तो full converter में भी नहीं चाहिए. हाँ? Chance. Freewheeling diode semi converter में लगाना optional होता है. C and D. Consider a single phase full converter with highly inductive load. If T3 becomes short circuited, which of the following consequences are plausible? देखो ये वाला मैं आपको कल पढ़ाऊंगा. T3 अगर शॉर्ट सर्किट हो गया तो आउटपुट वोल्टेज विल हैव द पीरियड वेयर इट इज जीरो. सोर्स करंट विल आल्सो बी zero for some time, and you will get converter can no longer control the output. ये गलत. देखिए यहाँ पे क्या होता है. T3, if T3 is short circuited, it is always on, so T1 is always off. ठीक है. अगर ऊपर वाले ग्रुप में से एक डिवाइस परमानेंट ऑन हो गई तो दूसरे वाली परमानेंट ऑफ हो जाएगी. If one device is permanently on, the other is always permanently off. So now T2 from the lower group alpha to pi plus alpha. So V0 will be 0, IS will be 0. And T3, T4 from pi plus alpha to 2 pi plus alpha. Why V0 is 0 in T3, T2? Because beta, they are from the same group. They are from the same group. ये एक ही ब्रांच के हैं तो V0 0 आ गया. So that is why beta V0 has a period where it is 0. IS also has a period where it is 0. So V average will be Em by pi cos alpha. So you can still control average output with the help of alpha. आप अभी भी अल्फा की मदद से कंट्रोल कर सकते हो. ठीक है. बख्शी जी फ्री व्हीलिंग डायोड तो फुल कन्वर्टर में भी नहीं चाहिए ना, तो ये एडवांटेज या डिफरेंस कैसे हुआ? फॉर सिंगल फेज फुल वेव कंट्रोल्ड रेक्टिफायर which of the following load will result in a continuous and constant load current? कॉन्टिन्यूअस एंड कांस्टेंट लोड करंट के लिए इनमें से कौन सा लोड इस्तेमाल कर सकते हो बताइए. बोलो भाई. ई सी. प्योरली इंडक्टिव में तो रिपल आएगा. इन प्योरली इंडक्टिव लोड रिपल इज देयर. इंडक्टर चार्जेस डिस्चार्जेस चार्जेस डिस्चार्जेस. तो यू कैन यूज बी एंड सी. चलो कम टू द क्लासरूम क्वेश्चन. फुल वेव ब्रिज रेक्टिफायर फीडिंग RE लोड ट्रिगर pulses continuously applied. Whenever you see this, remember SCR will behave as diode. So conduction will be from theta to pi minus theta. ठीक है. जब भी SCR डायोड की तरह बिहेव करेगा अगर आप उसे कंटिन्यूअसली गेट पल्स देते हो. Now see, it is a full wave rectifier. So period is pi. इंटीग्रेशन फ्रॉम थीटा टू पाई माइनस थीटा वन बाय 10 पाई now theta is sine inverse E by Vm sine inverse 110 by 230 19.7 okay 10.9 so answer would be 11 10.9 so my answer would be 11 very good Bakshi and Subhadeep chalo next full converter delivers power to a R load I need the average output voltage beta full converter with a R load and a semi converter both have the same average output voltage रिवीजन क्लासेस बेटा वो तो आरआईबी के अंदर चलती है ना उसी का तो एक सब्जेक्ट में यूट्यूब पे डाल रहा हूँ पेड में रिवीजन क्लास तो चलती ही है not average will be m by pi 1 plus cos alpha 193 point very good A answer single phase full converter delivers an output ripple free load current of 10 ampere average value of thyristor current in ampere average thyristor current तो बेटा थायरिस्टर कंडक्शन एंगल इज पाई तो आई टी एवरेज I naught 5 एम ठीक है आंसर विल बी 5 MP चलिए नेक्स्ट A single phase full converter supplies power to RLE load. Supply voltage RLE is given alpha is 30. I need average output current and voltage. If the load current is extinguished, that means beta is 200. If beta is 200, find the average output current and output voltage. चलिए Vm by 2 पाई क्यों होगा भाई तो? वो तो हाफ वेव रेक्टिफायर में होता है ना ये तो फुल वेव रेक्टिफायर्स हैं देखो, when you talk about average current, inductor does not have a role. Now you know alpha as well as beta will apply Vm sin omega t minus E by R d omega t. Now integration of sine will be minus cos 1 by R is to cos 30 minus cos 200 pi by 180. Okay. (46.25). Now what will be V naught, beta? I naught average R plus E. So 192.4. समझ में आया? What have I actually done? I have taken the integration of the current from alpha to beta. Whenever alpha and beta is given, my job becomes very simple. I know the interval of integration. मुझे interval of integration पहले ही मालूम है. And once I find I average current, V average is I average into R plus E. चलिए next one. SCR with peak forward voltage triggering of 2000, average current rating of 50 ampere. It is used in a midpoint converter and a bridge converter with a factor of safety as 2.5. I need the power handled by the two converters. मुझे दोनों कन्वर्टर की पावर जानना है. कंटिन्यूअस कंडक्शन का है. किसमें कह रहे हो? फोर्थ का डी. अच्छा सॉरी, डी आएगा. हाँ, 56 वाले पे लगा दिया. इट विल बी डी. करो अब अगला. अगला बनाओ. आया भाई आंसर? देखो, PIV is voltage rating upon safety factor. Thyristor average for a full wave rectifier is I naught by 2. Okay. For midpoint, PIV is 2 Vm. to 54.64 power 25.46 किलोवाट. ठीक है. For bridge, PIV is actually Vm. I'm not given alpha. So power, which is V naught I naught, 50.92 kilowatt. ठीक है. Answer will be A. Clear? चलो next. In a single phase semi converter with discontinuous conduction and beta greater than pi, the freewheeling diode conducts for beta minus pi. Freewheeling diode turns on for omega t greater than pi when V naught becomes negative and continues till I equal to 0 at omega t equal to beta. So it is beta minus pi. Okay. Chalo next. In a single phase semi converter with R load and firing angle alpha, each SCR and freewheeling diode conduct for. Each SCR and freewheeling diode will conduct for. बताओ. D. Because beta, in case of R load, V naught never becomes negative. So freewheeling diode never conducts. Okay. So the conduction angle of freewheeling diode is 0. A single phase semi converter is connected to 100 volt 50 hertz supply. Load is RLE. Alpha is pi by 3. I need the current distortion factor G. I need G. ठीक है. तो बेटा until beta is given, assume continuous conduction. ठीक है. जब तक बीटा ना दे दे आप continuous conduction ही लेके चलिए. You assume that the inductance is high enough to make I naught constant. आप ऐसा मानिए इंडक्टेंस काफी है करंट को कांस्टेंट रखने के लिए. चलिए. तो 2√2/pi alpha is pi/3. The total RMS alpha is pi/3. So G is fundamental RMS by total RMS, which is 3/pi. D option. Answer is D, 3/pi. Okay. Next, level 2. In a single phase semi-converter delivers power to RLE load with R, L and E mentioned. AC supply voltage is given. For continuous conduction, find the average output current if alpha is 50. If alpha is 50. There are two parts. First, solve the first one. If you solve the first one, you will get the answer, right? पहला आंसर भी आ गया तो बात बन जाएगी. तो देखो, for the first part, it is a semi-converter. So this is the average. One plus cos 50. $170.08. Now I naught is V naught minus E by R, 90/5. Okay. So from here I can say answer is C. But what about the next part, beta? Because the conduction is continuous, let me just copy the diagram. Whenever beta it talks about semi-converter, always take an assumption that it is basically symmetrical semi-converter. Okay. So let me copy the symmetrical diagram. Okay. चलो देख. Now beta it is saying that T3, one of the main SCR T3, let us assume it is open. Okay. Now for constant I naught, one of the upper two devices should conduct therefore T1 is permanently on. अगर T3 ओपन हो गया तो T1 को परमानेंटली ऑन रहना पड़ेगा बिकॉज मेरे बच्चों one of the two devices should always be conducting. Now D2 conducts from 0 to pi. So T1 D2 0 to pi. V0 will be Vs. T1 D4 pi to 2 pi. Not will be 0. So when you talk about average, zero to pi you are getting sine wave. So area of sine wave is 2. It will come out as Vm by pi. (103.53). What is the current? E is 80 by 5. 23.5, 4.6, 4.7. Okay, 4.7 एम्पियर. क्लियर हुआ? ये क्लियर हुआ? सेकेंड पार्ट कैसे करना है बेटा? Always remember for continuous conduction, one device from the lower group should conduct, one from upper group. Now because T3 is open, it is entirely the responsibility of T1 to conduct from the upper group. So T1 is permanently on. तो T1 तो full on हो गया आपका. चलिए next. A semi-converter employs two thyristor, two diodes. Due to malfunction, one of the thyristor is working as a diode. Now, it is feeding power to a resistive load. What is the average output? So, one of the thyristor is working as a diode. So, basically, now you have three diodes and one SCR. You have three diodes and one SCR. तो देखो ये वाला भी मैं कराता हूं. Suppose I say that this T3 is also working as a diode. And load is resistive. Okay. So this diode will also conduct from pi to 2 pi. Now see, from alpha to pi, D1, D2 on, pi to 2 pi, because now both of them are diode, both will be on, not will be minus V. You don't have to worry from 0 to alpha now because it is no longer a case of continuous conduction. Your load is resistive. So from alpha to pi, ES means Vm sin omega t. From pi to 2 pi, minus Vm Vm by 2 pi beta. Integral of sine is minus cos. So what is Vm? 200. 3 plus cos 60. 5 तो 111.408. ठीक है, that is your answer. समझे how to attempt this question from the basic? Understood beta? चलिए, now next I want is the power absorbed by the 4 ohm resistor. What is the power absorbed by the 4 ohm resistor? Here there is a AC source, there is a DC source. I need the power absorbed by the 4 ohm resistor. You can think of it as a RE load. तो देखो, this is a RE load. Theta is sine inverse E by Vm. 12 by 20.6. Okay. Now I need I naught RMS. It is a half wave rectifier. 1 by 2 pi. Diode conducts from theta to pi minus theta. Twenty sine omega t minus 12 by 4 square t omega. Okay. Four hundred sine square omega t plus 144. 400 sine square omega t is 200 minus 200 cos 2 omega t plus 144 minus 480 sine omega t. Okay. So now beta, you can integrate and you can put the limits. I am telling you the answer. It will be 0.785 MP. Now power in the resistor is 2.46. Okay, that is how you have to solve it. ये समझ में आया किस तरीके से सॉल्व करना है आपको? चलिए, for the above question, power delivered by the input sinusoidal source. Now power from the input beta, power from the input is same as the power at the output. But at the output मेरे बच्चों, you have two elements, a resistance and a battery. So battery needs average current. So now basically you have to calculate average also. 1 by 2 pi theta up to pi minus theta 20 sine 2t minus 12 by 4 t omega t. 1 by 8 pi 40 cos theta cos 36.86 minus 12 180 minus 2 into 36.86, 73.72 to pi by 180. Okay. So that is how you can calculate the average current, beta. And the average current will come out to be 0.3875. So this value will be, the resistance power was 2.467, 7.117, like this, 7.117. Okay. Chaliye. Now the value of inductor is very large, so that load current is constant. What is the power delivered by the input voltage source? डायरेक्ट फॉर्मूला भी तो डायरेक्ट फॉर्मूला होता है। देखो डायरेक्ट फॉर्मूले की जो आप बात कर रहे हो ना, मैं आपको इसका शॉर्टकट बता देता हूं। तो Vm/2 number of diode plus number of thyristor to cos alpha, single phase bridge। ठीक है, ऐसे। So now because there is one thyristor, 3 diodes, so it will be 3 plus cos alpha। तो यहां पे आया भी 3 plus cos alpha। ठीक है, ऐसे कर सकते थे। चलो ये बनाओ। If the load current is constant, what is the power coming from the input voltage source? पूरे सब्जेक्ट का कुछ भी पूछते हैं, पूरा सब्जेक्ट कैसे याद करूं? देखो अगर गेट की तैयारी करोगे तो पूरा सब्जेक्ट याद ही रहेगा बेटा, कॉलेज प्लेसमेंट में भी काम आ जाएगा। उज्जवल बनाओ इसको। चलो देखें, आप देखो V0 would be, this is a diode rectifier, so I0 is V0 minus E by R, because it is saying continuous conduction 0.3415, so power is V0 I0, 2.174 watt। Simple. Power is 2.17। चलिए try the next one। Input voltage is periodic, it is filtered, consider the system। ये जाने दो, it has nothing to do with the rectifier। ये वाला देखो यार, see this question. IRMS स्क्वायर इंटू आर, बेटा वो आर ई लोड में होता है, ये हाईली इंडक्टिव लोड है, विच मीन्स आई नॉट इज कांस्टेंट। ठीक है बख्शी जी। फॉर द सर्किट शोन बिलो विच ऑफ द फॉलोइंग स्टेटमेंट इज फॉल्स? कंडक्शन टाइम ऑफ द डायोड, देखो कल इस तरह का क्वेश्चन हमने किया था ना, दिस इज अ एलई लोड, दिस इज अ एलई लोड, तो व्हाट हैपेंस, conduction starts at theta, so theta to pi minus theta, it is charging, and from pi minus theta onwards it is discharging. So conduction time is independent of L, it depends on theta. Okay, conduction time depends on theta. ये कल कराया था ना एलई लोड में, आई डिराइव द पीक करंट फॉर यू, तो आंसर विल बी बी। एवरेज वोल्टेज अक्रॉस द इंडक्टर, सॉरी ए आएगा, फॉल्स पूछा है। दिस इज करेक्ट, दिस इज करेक्ट, दिस इज करेक्ट, तो आंसर इज ए। चलिए नेक्स्ट, which of the following statement is correct for the circuit shown below? Now see the circuit carefully. We are applying a sinusoidal input and we have a full wave bridge rectifier with a RLE load. मेरे पास RLE लोड में एक क्या है, फुल वेव ब्रिज रेक्टिफायर से मैं चला रहा हूं। Now if load current is continuous, D1, D2 and D3, D4 will start conduction when Vs is greater than E. If it is continuous, average will be more than 2 Vm by pi. If it is discontinuous, average will be more than 2 Vm by pi. A and C options are correct. Now beta, in continuous conduction, for continuous conduction, RLE load behaves like a RL load, which means D1, D2 will conduct from 0 to pi. D3, D4 from pi to 2 pi. There is no role of E in deciding the conduction. If load current is discontinuous, average will be more than 2 Vm by pi. So 2 Vm by pi is for continuous. I told you beta, in discontinuous average is more than continuous. Discontinuous का average हमेशा continuous से ज़्यादा आता है, so that is why C is correct. C is correct. ठीक है, ये वाला जाने दो, ड्राइव का सवाल है, ठीक है, नॉट नीडेड। चलिए, so let us complete the assignment that we left yesterday. SCR is required to give a average power of 0.5. Gate voltage is varying from 2 volt to 10 volt. Triggering gate pulse of duty cycle 0.6. Average gate power dissipation will be. Average power dissipation 0.5 देना है. थोड़ा अजीब है, एवरेज दिया भी है. क्वेश्चन में मुझे यही गड़बड़ लग रहा है, एवरेज दे भी रखा और एवरेज पूछ भी रहा है. इसका यार 0.5 ही है, बिकॉज एवरेज इज गिवन एज 0.5. जस्ट अ मोमेंट, ये देखो जरा. हाँ भाई. For a SCR, gate cathode characteristic is given by a straight line with a gradient. Gradient means slope. So Vg is 20 Ig. Maximum turn on time is 4 microsecond. Gate current required is 400 milliampere. So what is Vg? It will be 8 volt. Now Rs is Es minus Vg by Ig. Source voltage is 15, Vg is 8, Ig is 0.4, 7 by 0.4, 70 by 4, 35 by 2, 17.5 ओम. ठीक है, यही आ रहा है. 6 क्वेश्चन भी छोड़े थे हम लोग कल. मेरे ख्याल से लेवल 1 तो कर लिया था ना, लेवल 2 ही तो छोड़ा था कल हम लोगों ने. लेवल 2 ही तो छोड़ा, जितना याद आ रहा है. हाँ ये तो कर लिया था यार हमने. एवरेज पावर डिसिपेशन 1 वॉट आया था. 6 हो गया था पक्षी जी. Given that pulse width is equal to turn on time, average power dissipation is 0.2 watt. Maximum triggering frequency that is possible when pulse firing is used. So pulse width is 4 microsecond, which is less than 100 microsecond. Gate power is the maximum value. EG 8 into 0.4, that is 3.2 watt. Now beta, PG average is always duty cycle into PG maximum, which means duty cycle is 0.2 by 3.2, 1 by 16, which is pulse width by T. So time period is 16 into pulse width, 64 microsecond. Frequency will be 1 by T. 15.625 kilohertz. Okay, so answer will be A. The thyristor has a latching current of 50. It is fired by a pulse of length 50 microsecond. What is the value of R? So beta, this current should be 50 milliampere at the end of the pulse width. Now I1 will be 100 by 20. 1 minus 5. Tau is 0.25. 50 microsecond. 0.05 millisecond, and it is 25 milliseconds. milliampere. Okay, this comes out as 10 milliampere, बच्चों. So I2 should be 50 minus 10, 40 milliampere. So R should be 100 by 40, 2.5 kilo. Okay, 2.5 kilo. Latching current for SCR between DC source and the load is 100 milliampere. Minimum width we have to find. So current is 200 by 20. 1 minus e to the power minus t by tau. Now the latching current is 100 milliampere. Tau is L by R, 0.01. So what is T? 100 microsecond. Okay. A thyristor data sheet is given as 1.5 volt 100 milliampere as gate trigger voltage and current R is connected. Resistance is connected across the gate cathode terminal. You are connecting 20. Want this R. Okay. So the gate to cathode voltage is 1.5. This is 100 milliampere, or you can say 0.1. So this current will be 1.5 by 20. So it is how much? 0.15, 0.075. 0.175. So R will be 8 minus 1.5 by, so 6.5 by 0.175, 37.14. Okay, very good. Answer is B. Power diode final voltage across the capacitor. This we had already derived, beta. 190. Get 2Vs minus V. Okay, तो आज मैं अगला असाइनमेंट नहीं करा रहा हूं. That we will discuss tomorrow, and tomorrow also we will meet at the same time. Okay, तो कल भी same time class रहेगी 11:30. Lecture number 7 we will complete single phase and we will start 3 phase. चलिए, so thank you everyone. Have a great day ahead. और देखो मैं YouTube वाले बच्चों को बता दूं बेटा, अभी 70% ऑफ चल रहा है RIB पे। अगर आपको बाकी के सब्जेक्ट भी रिवाइज करने हैं तो यू कैन बिकम अ पार्ट ऑफ आवर रैंक इंप्रूवमेंट बैच। जस्ट गो टू द गेट बैचेस लाइव सेक्शन, चूज द उम्मीद और उन्नति based on whether you are from electrical or EC and use the code YT70. And if you want the GATE comprehensive batches for 2026, they are also available at 70% off. That is using the code YT70. But if you want to join recorded course for GATE 27, it is available the new batch at 30% off using the code EB30. GATE 26 test series is available at 70% off using अंकित ESE। ठीक है, सेलियंसी का